He was a morbidly obese surgeon destined for an operating table and an early death. Now he's a rebel MD who is fabulously fit and fighting to make America healthy again. This is Stay Off My Operating Table with Dr. Philip Ovadia.
And we're live. Hey, folks, it's Stay Off My Operating Table with Dr. Philip Ovadia. We are recording this in the just about as the sun breaks over the horizon for both myself and our guest. We thought he was going to be recording from the other side of the world, and then things happened, and now he and I are in the same time zone. Phil has been awake for a couple of hours, I can tell. I'm not going to complain a lot more, Phil. Let's go ahead and just get this conversation started.
Awesome. Really excited to have our guest on, Dr. Adeel Khan. Dr. Khan is one at the forefront, one of the leaders in a field that we call regenerative medicine. And that's not something we've had the opportunity to talk a whole lot about yet on the show, but I am excited for the conversation because it really intersects a lot with what we typically talk about, and
Yeah, I
ultimately
got a million questions already.
how to stay off of operating tables. I'm just going to let Dr. Khan maybe introduce himself. And we always like to hear the story behind how you got out of the typical medical system.
Yeah.
Because you are traditionally trained like I am, and then ended up taking the different path. Why don't you start off just telling us about that, and then we'll get into the nitty gritty of it.
Yeah, my origin story, so to speak. So I trained, like you said, as a traditional allopathic medical doctor in Canada, and I chose to do sports medicine, and I worked with a sports doctor for about 6 years. And as in sports medicine, we're treating injuries and pain, and the options in traditional medicine are traditionally cortisone injections, physiotherapy, pain medications, and surgery, and not too many other things to be offered. And I got interested in this field because part of it was I was working with this doctor who was specializing in regenerative medicine using plasma injections like PRP, platelet-rich plasma, which almost probably everyone has heard of now. But just to remind people, it's just basically where we take your blood, we concentrate the platelets, and the platelets are like little messengers that help with healing, and they can facilitate regeneration. So it was a very interesting concept. And it was just cool that, hey, your body has this natural healing mechanism inside of it. And the whole reason I was interested in this in the first place was in medical school and just in general, I was always fascinated by the fact that we were learning how to treat symptoms, but not really learning how to address the root cause. And just for my own family and my own friends and my own people who are close to me, like my mom and parents, and just understanding that they have these different chronic diseases, and the fact that we're not really solving the problem never really made sense to me. So philosophically, I was always okay. There's something missing here, and so that's why I got into functional medicine, integrative medicine. I studied all that stuff, and I was interested in it. And regenerative medicine to me just seemed like the future of solving all these things from a root cause or systems biology perspective of actually restoring the system as a whole and making it work together. And that's why I got super fascinated with it. And then I got involved in a Health Canada approved clinical trial for with using what are called autologous from your own body stem cells. And this was for osteoarthritis, which is a degenerative joint condition. And basically, as I got involved in that, I went down the whole rabbit hole of stem cells and then gene therapy and tissue engineering and all this stuff. And then I just got obsessed with it and traveled the world and met different scientists and met scientists in Japan that were doing some innovative work, scientists all over. And so that led me to doing some innovative procedures and bringing some innovative technology over to this side of the world where other people weren't doing it. And I think just getting a lot of interesting conversations going and helping make these therapies more accessible is ultimately what I want to do. So I think it's an exciting time to be in this field because it's not just going to revolutionize orthopedic care, which is obviously what I focus on, but also I think longevity and general chronic disease management because they'll actually treat the root cause and restore the system functionally.
Yeah, so at its basis, regenerative medicine, we're talking about really allowing the body to repair itself, rebuild
Hmm.
tissues that have been damaged. And this is something traditionally we would think of if something was torn, right? A tendon was torn, right? The only way to fix it is going to be go in there surgically and suture it back up. And what you've been exploring with these different modalities is, can we facilitate the body repairing itself essentially? Is that would you say an accurate kind of way to
That's exactly
explain?
how I explain it. It's
Yeah.
basically giving your body the right signals so that it can heal itself. And we're starting to understand what those signals are. And peptides can be part of that too. Shockwave therapy, I mean, hyperbaric oxygen. There's so many different things out there now that can facilitate healing and regeneration.
Yeah, so at a high level, looking at all of the various tools, what do you think some of the barriers have been to getting these into the mainstream, used widely, and maybe becoming an option versus surgical therapies or something to try before surgical therapy? Why has it been so difficult to get some of these treatments out there?
I think one of the biggest reasons is the lack of standardization. So in the stem cell world, the problem was and continues to be that we're taking the just to so people understand it, a stem cell basically is like a blank slate. A true stem cell is able to turn into different types of cells in your body, and it has this ability to self-renew, which means it can actually repair and regenerate tissue and replicate itself. But the problem continues to be that we're taking the stem cells from different sources. For example, we can take them from your fat, your bone marrow, umbilical cord, and they have what's called a heterogeneous population, which means a mixed cell population. There's different cell subtypes in there. And so the outcomes aren't always very consistent. So that's been one of the biggest issues. And then I think that lack of standardization leads to variability in results. And then it also leads to, there's also been a lot of misinformation, I guess, from the clinical side too, because obviously regenerative medicine is private and it's not covered by insurance yet. And so I think a lot of people were taking advantage of that opportunity to say, hey, we have the latest and greatest, and giving patients hope for a lot of things that may not necessarily be true. So I think that also has held back the field. And the regulatory environment in the US is also not favorable for regenerative medicine. And that's being, if you look from an objective lens, if you look at the universal kind of like landscape around the world, there's so many more progressive ways to do it where, for example, I always bring up Japan, where they have a regulatory framework that allows for these regenerative therapies that have proven safety. So they've done phase 1 trials to go directly into the clinic with market surveillance and monitoring for ongoing adverse effects and for efficacy as well for 7 years. So basically, this allows for cutting edge regenerative therapies to get into the clinic faster. But in the US, you have to go through phase 1, phase 2, phase 3, and then post market and everything. And that can cost $100 million. And if you don't have a big pharmaceutical company kind of backing up a specific cell therapy product, you're not going to get that stuff approved by the FDA, which is why, interestingly, it's coming full circle. Florida, Tennessee, Utah, Montana, all these states just in the past year really have decided that their state law will now be different from federal law, meaning they're allowing for these cell therapies, these what are called allogeneic or donor stem cells, even though they're FDA unapproved. So it's very interesting what's happening in the US right now. So we are officially allowed to do these therapies in the US in certain states.
You answered the question that immediately sprang to mind about the regulatory environment here in the US. Why do you suppose it's been that way? And it's simply because the people who can make money from the status quo are indirectly in charge of the regulatory environment and make sure that people without $100 million to spend on a test, on a study, can't get anything done. I'm going to say it that plainly because I don't have a medical license to lose. Thank you.
Yeah, that's a right way to put it. Unfortunately, there's something called regulatory capture. It's a well-known kind of phenomenon, and there's a
Yeah.
lot of influence by big pharma and whatnot into the regulatory bodies that be. And I think, like I said, it's not like you have to reinvent the wheel. You could just copy other countries, like in Asia, where they're doing this stuff and they're allowing for it and they're doing it in this way that makes sense. So I think if they really wanted, they could have made these therapies much more accessible a long time ago. But I don't think they want to necessarily because it's going to disrupt the status quo. As I'm sure, the whole concept of I know your story, Dr. Ovadia. That whole idea of treating the root cause and keeping people off your operating table isn't good for business, right? And so it's the same thing with these regenerative therapies. If you can disrupt a lot of the traditional industry, especially in orthopedics, where you can avoid surgery for a lot of things. And orthopedic surgeries is a huge generator of revenue for hospitals. I mean, I think that definitely plays a role.
Yeah, and I think ultimately for the practitioners in the future, right, for you and I, right, the trick is figuring out when those, we'll call them traditional treatment paradigms, the surgery is indicated, and when we can avoid it, right? I'm sure you heard during medical school, one of the things I heard during medical school, right, was the difference between a good surgeon and a bad surgeon is knowing when not to operate. And I think the more that we can open our minds as practitioners to alternative, and for those that are listening, I put that in air quotes, right? These treatment modalities that should have a very valid role in our overall treatment paradigms, and figuring out when those are the right thing, when surgery or even pharmaceuticals might be the right thing, but bringing those options to our patients. Maybe that then leads into the question of, if you're a patient out there, right, what are some of the situations that they should be thinking about? Is something like stem cells or something like peptides and some of the other modalities that you mentioned, when might they be applicable? What should maybe set off an alert, right? If you go to let's say the traditional orthopedic surgeon and the only thing they're saying is, we got to operate, what are some of the things that might indicate to a patient that maybe there are some other things that could be tried first?
Yeah, I mean, I think orthopedics, of course, is one of the biggest ones that we've talked about. So we might as well dive into that a little bit. And the most common orthopedic condition is, of course, osteoarthritis, which is a degenerative condition where you start losing the getting of the cartilage, and the bone underneath is called the subchondral bone can also become damaged. And traditionally, if the cortisone injections and pain management and just call it, we're called hyaluronic acid, collagen injections, if those things stop working, then I mean they may offer PRP, which we talked about, and then sometimes but then they'll typically, if that doesn't work, then they'll offer a joint replacement. And I think that's a very much a disservice to the patient. I just think about my mom again, she had knee issues, and if we helped her to avoid knee replacement, and I think a patient deserves the same option at least, and then they can decide, do I want to do this? Yeah, like you said, alternative option, even though there is a very good evidence base that's building up for these therapies. So for example, just to give people, and there's a study done in France called the Hennegu study, which is like a famous kind of study in stem cell world, where they injected these bone marrow stem cells directly into the bone. It was called intraosseous injection, and then into the joint as well. And they did 12-year follow-up. And so it's a long-term study. And they found that only one patient needed to go on to needing joint replacement, versus in the joint replacement group, there's 4 people who needed like revision surgeries. So you could argue that long term that these treatments can be just as effective as joint replacement, if not better, in the sense of having less issues down the road. And so, and of course, there's much less risk initially. You always, whenever you're considering a medical intervention, it's always about harm versus benefit, or if you want to get technical, number needed to treat versus number needed to harm. But basically, we want to understand, if we're going to offer something to our patient, why not offer them this treatment that has potentially less risk? I mean, definitely has less risk, right? It's not surgery; it's just an injection, so definitely there's less risk with it, less recovery, less downtime, less rehab costs. and potentially the same upside or similar upside. Why not? So that to me is the way you can gauge if it's appropriate to at least offer it. And I think our osteoarthritis is definitely one of those places. And then it's only getting better. Like now we have better stem cell populations, and there's hydrogel technologies which can act as scaffolds for these stem cells. So it's only the improvement is only going to continue to evolve over the next few years, making these treatments even more effective, which means that even with what we had available 5 years ago becomes okay, yeah, it was good for 5 years ago, but now what we have is even better. And so that's the exciting thing about this space. And one of the other areas that's obviously one of my favorite areas, and I think a lot of people are interested in, is longevity. And I am obsessed with this concept because I think it's just so, the whole aging thing is so fascinating, and why we age, and can we do something to perhaps slow down the process, or maybe one day even solve aging as a disease. I think that area is just exploding. And these therapies, regenerative therapies, work through what's called epigenetic reprogramming. And essentially what that means is your epigenetics are what turns on and turns off certain genes. And over time, you have something called epigenetic drift, which is almost like a blurring of the instructions of what your cells are supposed to do. So your cells start to lose their identity, and they start to make mistakes.
The Xerox of a Xerox.
Yes. I don't know that saying.
Oh my God. Oh, I'm so old. A photocopy of a photocopy.
Oh, yes. Okay. Yes, exactly. And that photocopy over time becomes more blurred and less clear, and there's water damage. And so the worker bees in your body who are making the proteins can't read the instructions as well. And so there's more mistakes happening. And part of the core reason why we think we age, not to go too much off on a tangent,
No, I'm fascinated in this as a guy who knows what a Xerox is.
Yeah, interestingly, it's actually a mitochondrial DNA that photocopy over time is making mistakes, and that's where we think the problem starts. And there's a specific enzyme they've identified called polymerase gamma, which is like the enzyme responsible for that copying process that doesn't do its job as effectively as over time, and therefore more mistakes are made. And that mitochondrial DNA is essential to the aging process, because when there's mistakes made, there's something called oxidative stress, which are like these little free radicals that damage the DNA, both the nuclear DNA and mitochondrial DNA and the cell membranes. And over time, that's what drives the aging process. So it's really interesting, because if we can repair the mitochondria specifically, then we may be able to slow down the aging process significantly. And that's why mitochondrial transplantation and all these other areas around it are becoming a hot area of research. But coming back to longevity and these regenerative therapies, the stem cells can work via repairing damaged mitochondria called mitophagy, and they can even do what are called, there's been electron microscope studies where they've shown that they make little nanotunnels, which is almost like a little bridge between the new cell and the old cell, and they transfer mitochondrial DNA. So then so you're functionally making the cell you're making it functionally younger and work better, which is really cool. And we're starting to gather some real world evidence where we recommend everyone who does our longevity treatments to measure their speed of aging using these epigenetic clocks. And now we have something called proteomics. Proteomics is mapping out the proteins in your body, and is a very accurate way to gauge aging in the body. And we can see before and after how much we reversed or slowed down the aging process, which is really fascinating. And sometimes you see significant number decrease or rate of aging decrease. And of course, then subjectively, people notice things too. So I think those are some of my favorite applications, but there's also so many different chronic disease applications for these therapies, for peptides and for stem cells. Yeah.
So the thought occurs to me, let's assume that we crack the code in terms of aging. What's happening at the cellular level that causes that we label aging? Suppose we crack that code and are able to stop aging biologically. How does that cascade down through our health? How many of the health problems that we deal with on a daily basis are strictly age related? How much will these be solved? I realize I'm asking you to quantify what's probably unquantifiable, but
It's somewhat. because 90% of people over the age of 60 have a chronic disease, and most chronic diseases are age-related. So
And what does that mean in the context of this cellular aging? When you say they are age-related, these chronic diseases are age-related. It's not just that we've been on Earth for 60 plus years. What's it mean at the cellular level? What's that actually mean?
it means that these functions, there's called these 12 hallmarks of aging. And so we talked about one of them, which is a mitochondria, but there's not to get too technical, but
You know
for
what?
example,
We get nerdy and sometimes it's too much, but right now I think it's absolutely fascinating.
yeah, so there's something called senescence associated secretory phenotype, SASP, which is basically the zombie cells in your body. So certain cells die, but your body can't clear them out, and they continue to release inflammatory signals. Your immune system becomes dysregulated, and this is what's called inflammaging, which is one of the biggest drivers of the aging process too, is this chronic inflammation, which comes from immune dysregulation and what's called immunosenescence, where your immune system isn't doing its job as effectively as you age. And there's something called telomeres, which are like—
I was going to ask about that.
yeah, and they're like they always say the analogy is the shoelaces, the end cap of that, and over time they shorten as your cells replicate. And so telomere attrition is one of the hallmarks of aging. Gut dysbiosis has been added as a hallmark of aging too. Your microbiome becomes disturbed, and there's all these other ones as well. But the point is, those are the underlying processes that are becoming dysregulated just as a process as you get older, and because of cell replication and because of what we talked about earlier.
Of this copy of a
copy, exactly, yeah.
Okay.
And so invariably, what that means is when you get older, you have higher risk of cancer, neurodegenerative conditions, autoimmune conditions, heart disease, a lot of these chronic diseases that are plaguing the society, really. And they're not causing everything, but I think if we can solve aging, or at least get aging to a point where we can, let's say, really make a big difference in it, then we can, by association, reduce the risk of all these chronic diseases, or even maybe treat these, or even put some of these chronic diseases into remission. And I think that's very exciting. But to me, obviously, prevention is the future. With AI and with where the field and science is headed, that's going to be possible, I think. But even for now, if we can use these cutting edge therapies, such like we talked about, like the peptides and stem cells and whatnot, to get the chronic diseases into remission and get people off medications, that's still a very powerful modality then.
Now, how do you think about the interaction, right? When we're thinking about these age-related diseases, right, that obviously become more common as people get older, how do you separate out what is just an inevitable wear and tear that occurs within our system versus accumulated damage from our environment, right? And that includes the food that we're eating and the air that we're breathing and everything else that we are ultimately interacting within. And so how much of this becomes a battle against, if we could do a better job of preventing that damage by avoiding these environmental things, versus this is how much it's going to be inevitable no matter what your habits are, and what do we do to just tackle the design issues within the machine, we'll say.
Most people think the most dangerous room in your house is the bathroom, where you might slip and fall. But after decades of repairing hearts, I know the real crime scene is actually your kitchen table. It's where the slow motion heart attacks begin, one meal at a time. You've read my bestseller, Stay Off My Operating Table, and you know my mission. But now I'm going to the source. In my new book, Stay Off My Kitchen Table, we expose the metabolic evidence hiding in plain sight in your own pantry. Stop being a patient in waiting. Head to Amazon right now to pre-order Stay Off My Kitchen Table. Your heart and your future self will thank you.
Yeah, I mean, I think the inputs you put into your body are going to compound over time. So when you're older and you have, for example, you've been training and you have more muscle, that's going to give you more resiliency and give your body more capability of dealing with these dysregulated regulatory processes that happen. And same thing with even with the air we breathe, and there's these microplastics and heavy metals and things that accumulate. And I don't think, unfortunately, maybe I'm a bit pessimistic, but I think it's very difficult to change our environment at this point, and we're all going to get exposed to these things. And even with food, you can eat healthy, and obviously, I think a lot of people know how to do that, but a lot of people still don't do it. You know what I mean? And so
they're not suffering from a lack of knowledge here.
No, exactly. And so to me, I think humanity's and with AI, I don't know if we're necessarily gonna the whole world's not going to change in terms of the environment we set up, right? And so instead of trying to focus on that, my focus is building resiliency and tools so your body can deal with all the crap that you're putting in it. And because that unfortunately is not going to change too much. And that's why I think these tools are very interesting, because they do give you more resiliency to deal with those stressors.
Awesome. Let's talk maybe about a few of the tools. We've mentioned stem cells already, and I think people have a general idea of maybe what those are. But there's really been, like you alluded to, developments over the past 5 years, right? We have recognized that not all stem cells are the same, and
Yes.
there are some new things coming out on that front. So talk a little bit about where stem cells maybe have applicability, and maybe we can get into some of the breaking technologies like MUSE cells that I know you do work with, what those are, and just if someone says, I think I could benefit from stem cells, what they should be thinking about.
Yeah, it comes back to my earlier point where if you're thinking about getting stem cell therapy, you of course want to make sure it has the best chance of success. And the way we do that is by ensuring we have a standardized cell population. And the way we do that is through cell sorting technology now that we have, where we can take let's say the stem cells are coming from umbilical cord. And when you take that umbilical cord tissue after like C-section birth, the woman gives birth, you collect the tissue, and it turns out there's up to 10 different type of stem cell populations in there. So it's not all the same. So there's different cell populations with different cellular signatures. And what we can do is now we can isolate the best stem cell. And what makes the best stem cell is the ability to survive in the body. Number one, very important, because a lot of stem cells just die in the body otherwise. And number two, one of the big things is what's called pluripotency, which means the ability to turn into different cell types, but also being non-tumorigenic or non-cancerous, because the problem with other type of pluripotent stem cells is they can turn into anything, including potentially tumors. And so this is the unique ability of MUSE cells, because they're pluripotent, but they're non-tumorigenic by definition. And then they're also what's called stress-enduring cells. So meaning they can survive in harsh environments. That's what the SE stands for in MUSE. And because of that, we're able to use these cells as a standalone. So we can't get it to 100%, but we can get batches where it's like you have 90% of MUSE cells, and you have a standardized population now that you can inject and use as a therapeutic. And to me, I was the first one, I think, to really talk about it, because outside of Japan is where the MUSE cells were discovered originally. And then I met with a scientist a few years ago, and I realized all these clinics are doing stem cell treatments, but they're offering something called MSCs, which are what's called mesenchymal stem cells, which are from the same source that we talked about, but they're not true stem cells because they're more anti-inflammatory in nature and they're signaling molecules. So they can be helpful, but they're not regenerative in and of themselves. And it's always funny and sad at the same time, because the guy who discovered them, and Dr. Arnold Kaplan, he wrote a paper in 1991 naming them. And then in 2017, he wrote another paper saying, I named them incorrectly. I'm sorry. Please change it to medicinal signaling cells. They are not stem cells. But that paper, unfortunately, didn't get the attention it deserves. And it also was not really, I guess, a lot of stem cell clinics that were making money didn't really care to read it or to care to change their narrative. They continue to push stem cell. And that's part of the reason the stem cell industry has a bad name, is because they're pushing a lot of misinformation. And I was trying to just be honest with people. And the more you learn, and the more you know, the more you realize you don't know, right? And then that was just like the path I went down, and realized that, hey, wait a minute, all these clinics are telling people they're doing stem cells, but they're not really stem cells. They're just signaling molecules, which may still be helpful in certain contexts, but it's misleading to the consumer and to the patient. And so when I came across the MUSE cells, and I just felt like this big breakthrough in something that could help my patients a lot more. And then, of course, I've been using them for the last few years in a clinical practice. And of course, it's been dramatically different from the old technology in terms of efficacy and seeing what it can do. So it's an exciting time to be at this field, I guess. And I think these cell therapies, I mean, MUSE cells may be one of the better options we have right now, but in 5, 10 years, there might be something else, right?
The
You know,
thought occurred to me, I'm sorry, Phil, but I got to ask this. When I was doing my research on you, I came across a term aesthetics. I'm assuming that simply because right now of the cost, it's primarily the bulk of the people who'll be using this are wealthy, and oftentimes the wealthy people use that money to make sure they just look younger, not just be younger, but look younger. Does this have aesthetic effects? Like,
Yeah, I mean, that's part of the reason a lot of these, I guess, celebrities get interested in it, because they are interested in obviously slowing down aging systemically, but they're also interested in the aesthetics. And these therapies can be applied to your hair and face.
okay,
And
that's where I was going.
yeah, and basically, yeah, the hair stuff is actually pretty amazing. I mean, you look like you still have some hair there, so it might be
I've got a little
possible, but
bit. It's a waste of space, but yeah, I've got it.
yeah, but the point is, it can be pretty dramatic. It's a lot more potent than PRP, because there's a lot more signals in there, and of course, the Muse cells, because of their ability to actually regenerate and repair, they can wake up dormant hair follicles, and so it can be pretty remarkable for that. And then, just to your point about the cost, I think it's important. One of the things for me has always been about accessibility, which is how do we actually make these treatments more affordable? And there has been other technologies and other groups in the world who've identified how to make Muse cells in more efficient ways. And then, because they can make them in more efficient ways, then the cost of manufacturing goes down. And then all of a sudden, instead of the stem cell cost of manufacturing goes down, let's say 3 or 4x, and now all of a sudden you have a product that you can offer to the patient that's 3 or 4 times cheaper. So that's what's happening now, is that there's innovation happening on the manufacturing side. And because of that, the costs are going to come down.
now we talked earlier about regulation, right? And how regulation can be a barrier to these things. But there is also a legitimate role, right? And since this is largely unregulated, and especially as you get outside of the US, it can become a free for all. So, what should people be on the lookout for if they're considering a treatment like this, so that they're not getting ripped off? How do people know what are the good practitioners and what are the good practices to go to for treatments like this?
Yeah, the biggest thing I always say is find a clinic or a group that ideally is actively involved in research as well. Because at the end of the day, regenerative medicine is still a lot of basic science, and it's an evolving field. And if they're not actively presenting at conferences or publishing data or involved in different biotech things, then they may not know and appreciate or have maybe the authenticity of actually wanting to move the field forward, and they might just be purely commercial, which these clinics for the most part are. And obviously, not to say I'm not running, obviously we have a business too, but at the same time, we do invest money and effort and time into trying to do some research and publish things, and trying to collaborate with scientists. And I think that's what you want to look for at this point in time, if you're going shopping for a stem cell clinic or provider.
Can we talk peptides now?
Yeah.
I'm an idiot. I'm one of those just biohacker dudes who goes, oh, this looks fun. Let's try that, which is obviously the reason that regulations exist, to keep idiots like me from accidentally killing myself. But our Secretary of Health and Human Services, RFK, recently announced that there's a whole bunch of peptides that are going to be moved from, I don't know, you can't get them for any reason other than research to something else. Because I don't know the level of your expertise, I don't know how much to ask you, but obviously you work in that field. So if you could give our eager audience what you've got.
Yeah, I mean, peptides have become a very hot field. And as you said, we want to ensure safety as the number one most important thing. And that's where sourcing quality really matters, right? And the problem is a lot of the peptides on the market and the what's called the amino acid sequencing. So a peptide is basically like a baby protein, right? And what makes up proteins are these amino acids. And so the sequencing of that is often done in other places such as China or India, and then they just bottle it in the US and they say made in the US. And so you have to be careful with that. And that's part of the reason why I think RFK made the right decision, which is that everyone is starting to do peptides anyway. Why not at least offer it in a safer environment where there's some regulation around it? And now you can get it through prescription, through compounding pharmacies, and ensure that there's quality and safety behind there, there's certificate of analysis. And so I think that's going to be fundamentally the most important thing. And that's part of the reason why I'm very particular in terms of peptide companies that I want to work with or associate with. And there's one called Peptual in the US that does their amino acid sequencing and sources all their raw ingredients in the US and does third-party testing and has certificate of analysis. So that at least gives you some checks and balances. And then in terms of the actual peptides, I mean, they're essentially a signal to your body, right? So the most famous peptide I think everyone knows about is probably insulin or Ozempic now as well. And Ozempic sends a signal to your body to make you more full or basically make you nauseous so you don't eat so much. And that can help you lose weight. And so there's different signals that we can manipulate to achieve different things. Some of my favorite peptides are signals that work on the mitochondria. And now you can understand why, because you understand the mitochondria is where all this aging starts. And there are, for example, there's a peptide called SS31 that works on something called cardiolipin, which is part of the electron transport chain, how energy is made in your body, and it can stabilize it and basically help the mitochondria to work more efficiently and repair some of the damaged mitochondria. And then that can help to give a boost of energy or potentially help with recovery. And then you can combine it with something like MUSE, which is then once you've repaired the engine a little bit, now you can rev the engine up and increase the output. MUSE can increase cardiovascular fitness and actually make you feel fitter inside the gym, which is really interesting. And again, it works through the mitochondria. So that's just one example of how these peptides can work. And there's hundreds of different peptides now, but of the 12 peptides you're talking about, a lot of those are, let's say, the foundational peptides that we use. So that those two mitochondrial peptides are examples of that. But then there's other peptides such as that you may have heard of, like the Wolverine peptides for healing and regeneration, which is BPC 157, TB4, TB500. And again, there isn't a lot of human clinical trial data out there on these peptides. There might be more in Russia, because in Russia they've been using them for decades, and I think there's probably more evidence there, but we don't have access to all that stuff. But in terms of what we can access, there isn't too much human controlled data on these peptides, but there's so many anecdotal cases. And when those anecdotal cases gets to a point where it's just, okay, millions of people have tried them and we know they're safe, like they're not causing harm, and a lot of people report benefits, then why not give them a try? And that real world evidence type of approach is the way society is shifting, but that really bugs a lot of traditional academic doctors, and I think also makes it very challenging for these regulatory bodies to know what to do when all these people are doing these unapproved therapies that they say that they feel like there's no evidence for.
I'd feel a lot more sympathy for the doctors who say that if they hadn't spent the last 70 years prescribing drugs that ultimately, that we found out later, were
And that's my argument
toxic
too.
and deadly.
If the system we had built worked so well, we wouldn't have the problems that we do. So something needs to change. And what's your argument? And that's my thing. If you have a better solution, I mean, if you do, I'm happy to hear it. But they just rather critique us and be negative than try to say, okay, maybe this is worth looking into.
Yeah, it always strikes me as, I mean, everything we do use today at some point was unproven, right? It had no evidence behind it, right? The first heart surgeries, we can point at, that's how innovation ultimately occurs. And I get the same feeling you do, right? That people just, the people that are benefiting most from the current system want to stand most in the way of progress.
Yeah.
We've been integrating peptides into our practice as well, and seeing the same things, right? They low risk, seem to be benefiting lots of patients in many different ways. And why shouldn't we be trying to push this forward and explore, new uses for them? And like you said, yes, you have to be cautious, want to make sure you're sourcing them from good sources and that they are being used responsibly. But it is encouraging to we start to see some of these barriers to their use coming down, because again, and you have maybe a unique perspective on this, because again, as we get into regulation here in the US versus regulation outside of the US, and from what I understand, you have international clinics, but now because some of these regulations are changing, you're starting to look at and you're starting to bring it back into the US. So maybe talk about what that has looked like, and your perspective on hopefully where we might be going within the US.
Yeah, I mean, I've traveled way too much the last few years, and I moved all the way to Dubai so I could be in a regulatory compliant area where we could offer these therapies openly. Peptides and stem cells are both allowed in Dubai, and now things have changed so dramatically, and it's crazy. And 2 years ago, I would have never thought stem cells and peptides would be allowed in the US. It just wouldn't. It didn't even seem possible. So now, so because of that, we are opening a clinic in Florida in West Palm Beach that should be ready later this year. And for me personally, that's a big deal because Florida is a lot closer to my home in Toronto than Dubai. So I'll probably move back to Toronto, and it's a lot easier and I can just go down there as needed. And then we'll keep things running around the other clinics in Dubai and in Cabo, we have a clinic as well. But the point is, I think now that these treatments are in a more the perception of having U.S. Treatments in the U.S. is obviously higher than going somewhere else, even a place like Dubai. I mean, so I think it's going to add more legitimacy to the treatments as well and make them feel like, oh, you don't have to go to some foreign place to get it done. You can just get it done here at home in North America. And so I think it's going to be really good for the field. But there's also going to be, I'm sure there's also going to be a lot of abuse, right? And there's probably going to be a lot of people who are just trying to maximize profits and not really doing things properly. And I think that's really where it becomes important for the data aspect of all this. So there's a company called Sedona Health that's using something called proteomics, which I mentioned briefly at one point. But basically, proteomics is mapping out thousands of proteins in your body to give you a gauge of what's happening in your body. And the proteins are the actual worker bees that have to do and allow for functions in your body, right? And so what happens, and proteins are the end product of gene expression, right? And so they're ultimately what happens is there's all these modifications and what's called post-translational modifications, whatnot that happen. So looking at the genes or epigenetics isn't as accurate as looking at the proteins because the protein is the final product. So, but historically, measuring proteins was really expensive and you had to use mass spectrometry and it would be thousands of dollars. And even there's a test called SomaScan that was like $5,000. But so most people aren't going to spend $5,000 on a test. But now this company got it down to about $600. And so, and that's obviously, again, because of just the technology and what they've been able to build with an AI model that they have. And because of that, they're doing a bunch of pilot projects with different peptide clinics where they're going to use their proteomic system to say, okay, now we've had 1,000 people use BPC 157. This is what happens to aging in their body. This is how long they should take it. If they take it for this long, if they do this dose. So that data will be really valuable and give us much more guidance, I think, on how to better fine tune these modalities. And so I'm super excited about the proteomics kind of revolution that's happening right now, I guess, because for me, as someone who's in the aging kind of field as well, it's just an exciting therapy to become more accessible and give us real data that is very applicable or actionable for clinicians.
Let me ask a question that I feel like I might finally have the people in front of me to be able to give me a good answer. I was raised on the Bible, and the short version of the question I'm really going to try to ask here. The early humans in the stories in the Bible were said to have lived hundreds of years, literally hundreds of years. And that particular set of stories, I always found just not believable, simply because we don't have any evidence, at least that I'm aware of, that the human body has the capacity to live that long. Is it possible, based on what you know right now, that this aging problem could actually be, I don't know if fixed is the right word, but dealt with?
Mhm.
Is it possible that, at least at the cellular level, that humans could actually live orders multiple times longer than we average lifespan is now?
I believe the possibility is very real because of the combination of understanding quantum biology, which is quantum
Oh boy.
biology just so quantum biology is actually a really hot topic right now in aging. I mean, all that really means is because quantum just means subatomic particles, right? And so these quantum biology, so it's just understanding how these subatomic particles, like electrons specifically, how they move, and understanding that their movement and their efficiency and is ultimately what's creating energy, and being able to manipulate that is one of the really interesting areas and being explored. But at the same time, where there's obviously something called quantum computing that's happening too, and with AI and whatnot. And so I think the quantum computing with AI will be able to solve problems of quantum biology that we haven't been able to figure out ourselves, and because there's trillions of processes happening in your body in every given moment. So there's no human who will be able to ever solve aging. But I think the possibility of AI with quantum computing is a real possibility one day, that there could be a really huge breakthrough in extending lifespan. So yes, in short, I do think that's a possibility, but it's going to be these technologies that are going to allow for that.
Oh boy, I would so love to just spend a couple of hours talking about that.
Yeah,
It's an interesting topic. Yeah.
it really is. And as we think about, again, the things that you and I did do previously or are doing, continue to do, right? As I think about each heart surgery that I performed and what does the future look like that this isn't necessary anymore, right? A patient has a heart attack or a patient is developing one of these chronic diseases like diabetes, and we can truly heal that, fix that at the cellular level, right? And I think it is ultimately a combination of course, there's going to have to be lifestyle, dietary factors that come into this, but also using some of these treatment modalities. And what does that world end up looking like where, you know, there really isn't any diabetes anymore, or it's all fixable? It's pretty fascinating to think about. So I think that's probably going to make a great part two when we have you back on. And certainly we'll need to do that because I think this was a good intro course. But why don't you let people know where they can find out more about the work that you do and maybe just about this field of regenerative medicine more broadly?
Yeah, I like to be a resource of knowledge for people, and that's the whole reason I started to get on social media. So, of course, I have Instagram at dr.akhan, A-K-H-A-N, and then we have our eterna.health website, which is our clinics, and we have resources and information on there as well. And yeah, and then we're just continuously trying to innovate and pioneer different therapies and educate people, really the public, about everything going on too. So this is going to be, I think, a very exciting decade, and I appreciate you having me on to share some insights into what's going on currently in the field, and hope it gets people a bit excited and maybe give some people out there hope too, who are dealing with some different illnesses and whatnot.
Yeah, we got real into some of the way the heck out there kind of stuff today, as well as some very specific here and now things. I fiddled around on your website at eterna.health, some good stuff there. So I encourage our listeners to go ahead and check that out if any of this interests you in the slightest. And for those of you who are thinking about playing with peptides, hey, Dr. Ovadia at iFix Hearts, they're working on it. They're using it now. So y'all jump in there and do that as well. All right. For Dr. Adeel Khan and Dr. Philip Ovadia, this has been Stay Off My Operating Table. Thanks for joining us. We look forward to talking to you next time.
Chances are you wouldn't be listening to this podcast if you didn't need to change your life and get healthier. So take action right now. Book a call with Dr. Ovadia's team. One small step in the right direction is all it takes to get started. Contact us at ifixhearts.com/talk. That's ifixhearts.com/talk.